Welcome back to High Country Gold and Silver. Today, I have one of those pieces that makes you stop and stare. Because at first glance, it looks like somebody sliced a solid sheet of silver right out of the earth and put it on a stand. That broad silver grey band has that melted metal look. And it is exactly the kind of material the Creede District in Colorado is famous for. And here is the fun part. This is not just a lump of metal. This is crystalline native silver and silver sulfide, laid down in a hydrothermal vein, riding on the gangue backbone of barite. In this video, we are going to do a slow tour across the slab. Then I will drop you into the mine and the district. And finally, we will connect the textures you see here to the epithermal system that built the Creede veins. If you enjoy this kind of ore geology deep dive, hit like, subscribe to High Country Gold and Silver, and ring the notification bell so you do not miss the next specimen. This piece is labeled native silver with acanthite and barite from the Bulldog Mountain Mine in the Creede District of Colorado. More specifically, it is from the 67 Stope, between the 9360 and 9500 levels. Those levels are named for the elevation in feet, so we are talking about ore pulled from high underground workings in the San Juan Mountains. The slab itself is big and dramatic for a vein cut, about 21.1 by 18.3 centimeters and about 0.8 of a centimeter thick, with a mass of 1,120 grams. Now let us take a slow look at what we actually have. The first thing you notice is that broad, continuous grey field across the face, almost like two big wings that meet along the center. The surface shows fine parallel cutting lines, so this is a deliberate saw slice through the vein. That is perfect for us, because a slab like this is basically a cross-section of ore texture, frozen in place. Around the margins you get the bright, chalky to snowy white gangue, and that is barite, barium sulfate. In hand specimen, it often has that heavy, blocky, sugary look. And along the edges here you can see rough, broken barite with little steps and crumbly fractures. That white barite forms a kind of frame around the metal-bearing core. Then the ore band itself. The light grey tone looks deceptively uniform at a distance, which is exactly why miners describe pieces like this as solid blocks of silver. The 67 Stope has a reputation for producing that kind of spectacular, massive-looking silver ore. But on this specimen, the label call-out is important. The silver and acanthite are crystalline and deposited on a barite matrix. So even though the grey band reads as solid metal, it is really a dense intergrowth of silver minerals and barite, with the barite diluting the overall silver content. If you track the contacts between the grey core and the white barite rim, they are not sharp, straight lines. They feather and scallop with irregular embayments. like the ore front advanced and retreated impulses. Along some of those boundaries, you also see darker, sooty zones and streaks. That darker material is consistent with acanthite, silver sulfide, and possibly other fine-grained, silver-bearing phases that show up as dark gray to black in banded epithermal ores. The center seam is another great teaching feature. There is a narrow, darker, more broken-looking zone running up the middle, with little fractures and tiny cavities. That looks like a reopened fracture, or a late slip surface that got re-cemented. In epithermal veins, repeated cracking and sealing is the rule, not the exception. The system breaks the rock, drops pressure, fluids flash and react, minerals precipitate, and then the structure moves again and repeats the whole process. This slab is basically a snapshot of that cycle. Recent smelting experiments on ore slabs like this suggest this specimen probably contains about 15 ounces of elemental silver, which is an impressive amount to be locked up in a single slab. And this is where that barite dilution matters. Visually, the grey band tempts you to imagine a near 100% silver plate. In reality, barite is taking up a lot of that volume, and the silver is distributed as crystalline, native silver and silver sulfide through that barite-supported ore fabric. That does not make the piece less exciting. It makes it more geologically honest, and it explains why these ores can look unbelievably solid, while still being a composite of metal and gangue. So how did the Creede system make ore like this? Geographically, Creede sits in the San Juan Mountains of southwestern Colorado, and the district is famous because it is a classic volcanic-hosted epithermal silver district. The big picture is caldera country. Explosive volcanism built thick sheets of ash flow tuff and related volcanic rocks, and caldera collapse created basins that later held lakes and sediments. In the Creede area, those caldera-related structures and their faults became the plumbing that focused hydrothermal flow. Historically, Creede's boom kicked off in the late 1880s and early 1890s, when development of major veins triggered a rush and sustained production. The district continued producing for decades, with silver as the headline metal and lead and zinc becoming very important as well. Then, much later, the Bulldog Mine became the key player. After 1969, nearly all production in the district was coming from the Bulldog operation, which ran from 1969 to 1985, and is famous among collectors for producing rich ore and great mineral specimens. Detailed work on the Bulldog Mountain vein system shows a sequence of mineralization stages and very strong zoning. One of the most important points for understanding this specimen is that within a major stage of ore formation, the Bulldog Mountain system becomes progressively more barite-rich and silver-rich, with increasing elevation to the south. In that southern higher elevation facies, native silver plus or minus acanthite can become locally abundant within barite-bearing ores. That description is basically a written caption for the slab you are looking at. Silver and acanthite presented as a thick, banded, apparently massive zone, but anchored in barite. Deposit style-wise, this is epithermal vein mineralization. Relatively shallow, relatively low temperature hydrothermal ore deposition in and around volcanic rocks. The veins show repeated banding and open space-filled textures. Those banded textures form when fractures open, fluids rush in, and minerals grow inward from the walls, sometimes in multiple generations. When you see broad continuous bands and rhythmic changes from barite-rich to sulfide-rich layers, you are seeing the record of those pulses. What actually drives the chemistry? In the Creede system, ore deposition is strongly tied to fluid evolution through mixing and boiling. Pressure drops in open fractures can cause boiling, which changes fluid chemistry fast and makes metals drop out. Mixing between different fluid intrusions can also trigger mineral precipitation by changing temperature, salinity, sulfur content, and oxidation state. In caldera settings, you can have meteoric water circulating down from the highlands and more saline waters interacting with caldera-fill sediments, all pulled through the same fault-controlled plumbing. The important point is that the vein minerals you see here are not random. Barite is telling you sulfate chemistry was in play, and the silver mineral suite is telling you the system hit the right conditions to move silver in solution and then dump it efficiently along these structures. From a collector standpoint, this slab is special for a few reasons. First is provenance. Bulldog Mountain Mine, 67 Stope, is one of those labels that immediately signals serious Creede silver. Second is the format. A large, thin vein slice is one of the best teaching tools you can own because it turns a three-dimensional vein into a readable cross-section. You can literally point to zoning, banding, reopen fractures, and ore fronts in a way that a chunky specimen does not always allow. Third is a mineral association. Native silver with acanthite on barite is a classic diagnostic look for the silver-rich, barite-bearing facies of Bulldog Mountain mineralization, and it ties directly into the published paragenesis and zoning models for the mine. If you want a quick mental comparison, think about how many famous native silver localities give you wire silver and delicate sprays. Those are spectacular, but they are a different kind of information. This slab is about ore architecture. It shows you how a hydrothermal system can build what looks like a single sheet of metal, when it is really a composite vein fill, grown and regrown during repeated pulses of fluid flow and fracture reopening. It is a textbook you can put on a stand. Alright, let us wrap this one up. This is a large, dramatic ore slice from the Bulldog Mountain Mine in the Creede District, where epithermal veins produced some of Colorado's most iconic silver ores. You have a barite gangue framework. You have silver and acanthite concentrated into a thick, continuous band. And you have textures that scream crack and seal vein growth. And with the added real-world note from smelting experiments, suggesting on the order of 15 ounces of elemental silver, you get both the collector thrill and the geologic reality. It looks like a solid block, but it is a beautifully engineered mineral deposit built layer by layer on barite. If you enjoyed this tour, please like the video, subscribe to High Country Gold and Silver, and ring the notification bell. And drop a comment telling me what you want next. More Creede slabs, wire silver, or maybe a completely different deposit type, so we can compare textures across systems. Thanks for watching, and I'll see you in the next one.